Okay, so this is problem number 13 about a bullet that's fired into a block that's acting like a spring. So we're trying to find the distance, how far it will go into the block until it stops like the spring. So first I write down all of the givens that we have, which is we have the spring constant and we have the initial velocity, and then which is 0 for the block because it hasn't hit the block yet, and then the mass, and then the mass for the bullet, and the initial velocity, which is what it's going, and then the final mass, which is these two masses added up, and then we're trying to find the final velocity so we can plug it into the conservation of energy equation. And so we use conservation of momentum, which is mv initial equals mv final, or otherwise mv plus mv equals mv final. And we plug in those, and we know that this is equals 0 because it hasn't hit the block yet, so it's, or when it hits the block it isn't moving, technically, for the conservation of momentum. And so the final velocity is equal to 1.493 meters per second, and that's before, that's right as it hits the block, right here. And then we plug in for the conservation of mass, it's kinetic energy plus potential energy initial equals kinetic energy plus potential energy final. And we put in these equations, and then we plug it in, and then this is equal to 0 for potential energy because it's still 0 meters per second, because the distance right here, it's just hit the block, so it's not going anywhere. And we're trying to find how far it goes, which is right here, that's why it's unknown. And then this is 0 because then it's the farthest distance. When it reaches that distance, then the velocity will stop. And then we further solve it, and we get 0.478 meters into the block.